Okay, we're going to talk about electron configuration part 2 today. Basically, I'm going to teach you the filling order and a little thing called noble gas shorthand. Okay, now after the fourth orbitals are filled, the electrons go to the third energy level and fill the 3D orbitals. Okay, so it goes from 4s to 3D. And this is because the 3D orbitals have a little bit higher energy than the 4s. Monday in class, I'm going to give you a little chart that has the order, basically that has the energy levels, so you can see why 4s is filled before 3D. In the meantime, I'm just going to give you the filling order. So let's go up here. Okay, the actual filling order is, hang on a second. Okay, so it's 1s, 2s, 2p, 3s, 3p, 4s, back down to the 3D, then we go to 4p, and then we do 5s, 4d, oops, okay, 4d, then 5p, and then 6s. Now, this is where the 6th row is where it goes into the F, okay, so at this point it goes to 4f, then it goes 5D, and then 6P. And then 7S, in the 7th row they do the same thing. They go back to the 5F, then the 6D, and then the 7P. Okay? And this is the best filling order we have. We don't have anything that's in an 8th row. There is no 8th row. So, truthfully, there are orbitals in 6F and 7f, but they're used more when the electrons are hit by a photon of light to jump up and emit light. They're not in the ground state. There's never electrons in either a 7d or a 6f or a 7f. Okay, there's just not enough electrons to fill them up, which is kind of good. Okay, now as far as this order goes, there's two things you can do. You can either memorize it, which I'm not going to require you to, or since I'm going to give you an index card for this next test, I would write this order down on my index card, and that way I don't have to memorize it. The quiz on Wednesday, actually I bumped the quiz from Tuesday to Wednesday, and the quiz on Wednesday, you do have to know your filling order up through I was going to do 4S, but I think I'm going to do through 4D, or 4P, I mean. Okay? That's as far as you have to memorize for Wednesday's quiz. Okay? I don't care about the rest of it. I would just put that down on an index card, but you need to know up through 4P, because those are all the elements that we use a lot, so I really need you to know those. Okay? Okay, so your homework last night, or Friday night, you had to go up through calcium. Well, after calcium is scandium. So let's look at scandium. Now, scandium has 21 electrons. Okay, so when we fill it, we don't have to use the orbital diagrams. You can actually keep track of the number of electrons as you go. Okay, and then we're going to fill up with 21 electrons. Now, you know all S's, remember S has 2 electrons, P's have 6 electrons, and D's can hold 10 electrons, and F's can hold 14 electrons. So when we put these in here, remember we're going to put a little superscript which tells us how many electrons. You have to fill up a full orbital before you can go to the next one that fills. So let's go do this. So 1s, 2 electrons go in there. 2s, another 2 electrons. 2p, 6 electrons. 3s, 2 electrons. Okay, now I'm going to stop right here and I'm going to count what I've got. 2, 4, 6, I got 12. So I know I can keep on going. Okay, so the next one's 3p. I'll put 6 electrons in there. So we have 18 electrons. 2 more, 18, 19, 20 electrons. So I only have 1 electron to put in that D. Okay? So if you count all the little subscripts, you get 21 electrons. So that's what you always have to do. Now, let's say I had put too many in that D. I just have to erase it and put the right number. No big deal. Okay, well, after scandium, let's look at titanium. Titanium has 22 electrons. Well, this should be pretty easy to do since we just did scandium. So we know it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d2. And just to be safe, I'm going to count up all my electrons. So I've got 2, 4, 10, 12, 18, 20, 22. 22 electrons. So I'm fine. Okay, next we come up to copper. Copper, silver, and gold do something a little funky. I'm not really worried that you know gold, but I'm going to put up copper and silver. You kind of need to know those two. Now, copper has 29 electrons. And when you go to fill them up, you think it's going to fill this way. You think it's going to be a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. And there's your 29 electrons. Only the problem is right here. For some reason, it is not very stable having 9 electrons in that D. What an element likes to do is put 10 electrons. So instead of having 3d9 and 4s2, what it does is it puts 1 electron here and then 10 electrons there. So it does 3p6, 4s1, 3d10. Why, I don't, as I said, well, I do know, but it'd be really complicated, so I'm not going into it. So just know that that's what copper does. Silver does something similar. Silver, which has 47 electrons. Oh, here, let's make it silver. It's the 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1, 4d10. Okay, so it does the same thing. It puts it the 1 and the 10. Those are the only two that you guys have to know that are really weird. Okay, now, I don't know about you guys, but writing all of this out is also kind of a big headache. So once again, scientists, especially chemists, we like to do shortcuts. So we like to do something called the, noble gas shorthand. And this is where we are going to look at the noble gas. Now, what is a noble gas? Noble gases are the last elements on each row. The last elements of each row. And they are called noble gases because they are extremely stable. They're unreactive. Okay, helium, neon, argon, krypton, xenon, and radon. You're not going to find them in chemical reactions at all. Okay, they've got the right amount of electrons. They're totally stable. They just kind of look at other elements and go, whatever. So basically, their electron configurations never change. So that's why chemists like to use them when we're talking about electron configurations of other elements because they are extremely stable. Okay, so in order to figure out what the noble gas shorthand is, I'm going to first do one of the elements that I hate writing them all out for, but let's look at lead. So lead has 82 electrons. Okay, this is an awful lot of electrons to put into the electron configuration, but I'm going to do it anyway. Okay, so we're going to do 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2. Now, if you look at your filling order, at this point it goes into the F's for the first time. So it's 4F14. Okay. Then it goes back up to the 5D. So 5D10 and then 6P2. Well, that's an awful lot to write. And it's a pain in the butt. So if you look at this electron configuration right here, if you count up all the electrons, that's 54 electrons. This is the electron configuration of xenon. Okay, so I can actually rewrite this electron configuration using noble gas shorthand, doing this part of it. So using xenon. Now after xenon is where it, we've got leads. So 5D, 10, 6P2. So that's a heck of a lot less to write. Okay, well, how do you figure out what noble gas to use, and how do you figure out what's left after it? Well, it's actually pretty easy. Okay, so let's take a look at the xenon part. Okay, if you look at lead, lead is in the 6th row. Okay, so we're going to look at the noble gas behind it. So xenon is the last element in the 5th row. So that's why we use it. So the first thing you're going to do, so step number 1 is find the row that the element you're going to be doing this with is in, okay? Then you're going to look for the last element in the row before it. Now, how do I know what to start with? Well, since lead is in the 6th row, the rest of its electron configuration starts with 6s2. Now, how do I know how many electrons to fill in? Well, let's take a look. Lead we know was 82, and xenon is 54. So by putting down xenon, I've basically accounted for 54 electrons. So 82 minus 54, and let me get my little handy dandy calculator out here. So 82 minus 54 is 28. So all I have to do is account for 28 more electrons. So 6s2, 4f14. Now I've done 16 electrons. 5d10. I've now done 26 electrons, so I only need 2 more. Pretty easy, huh? Okay, well, let's try another one just to make sure we're understanding it. Get my thing to move. Okay, let's try antimony. Now, antimony is SB. Okay, SB has 51 electrons. SB is in the 5th row. So when I look at my periodic table, I'm going to find the last element, the noble gas, in the 4th row. That happens to be krypton. Now, krypton has an atomic number of 36. So I know I need 51 minus 36. So 51 minus 36. I need 15 more electrons. Okay. Now, since SB is in the 5th row, I'm going to start out with 5s2. I put 2 in there. And then I'm going to go 4d. Now, can I put 10 in there? Yep. That gives me 12 electrons. That means what's left for the 5p is 3. So make sure, yep, 15 electrons. There you go. Okay, let's try one more. So So this time let's try, oh, I don't know, molybdenum. Now molybdenum is 42, okay? Molybdenum is in the 1, 2, 3, 4. It's also in the 5th row. So once again, I'm going to use krypton. Now I know krypton has 36 electrons, so 42 minus 36. So I only need 6 more electrons. So I'm going to start out with 5s2. I only need 4 more electrons. So at this point, I just put 4d4. And that's it. Okay. Some practice problems. Well, you do some practice problems. And I will have the answers on Monday. Okay, so I want you to do the full electron configuration for, let's do arsenic. And I want you to do noble gas shorthand for, we'll do astatine. Okay, so hopefully you can handle those two. I will see you Monday. Bye.